So the other compound inequalities that I did briefly mention were the or inequalities. Or inequalities. So in the or inequalities, maybe this is intuitive, but the solution for x, or whatever your variable may be, can actually be in one inequality or the other inequality. It can be true for one or the other, and either way, it is a solution for your variable, and that is perfectly fine. So let's look at an example of this. So the first example, or one example that we're going to look at is 7 plus k is greater than or equal to 6, or 8 plus k is less than 3. All right, so the first thing that we're going to have to do is we're going to have to simplify these inequalities. Well, that's easy enough. Let's just bring this 7 to the other side. And we're left with k is greater than or equal to -1. Or bring this 8 to the other side, subtract 8 from both sides, and we're left with k is less than -5. All right, so now we're at a point where we can actually graph this compound inequality. So we're going to make a number line. Here we are. And I am going to make some tick marks, and we can make the 0 here. And these go on for infinity in both directions. And we have 1, and then we can go into the negatives. -1, 2, 3, 4, 5, 6, 7. So all the way down to -7 and -1. All right. So the first one that we want to look at is k is greater than or equal to -1. So greater than or equal to, that tells me already that this is going to be a closed point on -1 on our number line. So let's do that now. Make a circle, and I'm going to fill that in. Now k is greater than or equal to -1. That would indicate everything greater than -1, but I'm not going to draw that yet. Let's look at our other inequality. We have k is less than -5. All right, -6, -5. Here's -5. K is less than would mean an open point because k cannot be -5. And then k is less than -5. Well, that would indicate everything less than or into negative infinity from -5. All right, so now I think I have enough information to start drawing in all of our possible solutions. So our solution can be anything greater than -1, greater than or equal to -1, so all of this, or less than -5. All of these numbers, all the way into negative infinity. So both of these inequalities are actually true. So or indicates that either inequality can be true. That is the essence of the or compound inequality. Okay, so just to go over one more time, I just want to verify that everything is still fresh. So we have and inequalities and or inequalities. And with and inequalities, we have the graph of an and compound inequality must be the intersection of the graphs of the two inequalities. The intersection, so must be the intersection and you don't really need to know this notation, but an interesting notation would be that right there, which is actually indicates an intersection of the graphs of the two inequalities. And with the or compound inequalities, the graph must be, well, not must be. Let me rephrase that actually. Not must be. We're gonna say the graph is the union and then an interesting notation for this is actually like that. It is the opposite of the intersection notation. Another thing you do not need to know, but just out of interest, is the union of the graphs of the two inequalities. And that is all. We've discussed and compound inequalities and or compound inequalities. And that is all for compound and regular inequalities.